Hi everyone, I'm Joachim Baumann, and in this video I'll be discussing our FACT 2022 paper titled Enforcing Group Fairness in Algorithmic Decision-Making, Utility Maximization under Sufficiency. More and more decision-making systems rely on predictive models. However, there is a widespread recognition that those machine learning-based tools can go horribly wrong in practice. This can result in a number of problems, such as unfairness or injustice. Usually, prediction-based decision-making systems are not specifically optimized to ensure fairness. Instead, rational decision makers would rather optimize their utility. One of the remedies the community has proposed is the enforcement of certain parity constraints. And in this paper, we discuss how these constraints can be satisfied using post-processing techniques. These so-called group fairness criteria are concerned with outcomes of algorithmic decision-making on individuals' lives. The goal is to avoid systematic disadvantages across socio-demographic groups. Many different group fairness criteria exist. However, the most popular ones are independence, separation, and sufficiency. In most cases, these criteria are mathematically incompatible. Therefore, we need to choose one group fairness criterion over others. We know that for independence, conditional statistical parity, true positive rate parity, and false positive rate parity, group-specific thresholds are optimal. Additionally, Hart et al. Have showed that for separation, which is a combination of true positive rate parity and false positive rate parity, optimal decision rules instead take the form of randomized group-specific thresholds. However, for the remaining group fairness criteria, a similar result is still missing in the literature. And in our paper, we close this gap. We provide a formal proof showing that optimal decision rules satisfying positive predictive value parity always take the form of group-specific upper or lower bound thresholds. And the same is true for false omission rate parity. Furthermore, we show that in order to satisfy sufficiency, it is optimal to apply group-specific thresholds. And in most cases, these thresholds must be randomized for all but one of the groups. The exact form the optimal decision rules under any of these three criteria take depends on the group's probability distributions, on their sizes, and on the decision maker's utility function. In our paper, we show this in more detail for the case of recidivism risk predictions using the COMPASS dataset and based on a synthetic dataset. Existing work on group fairness for machine learning-based decision-making usually just considers group-specific thresholds, and we show that for three group fairness criteria, this is not necessarily the case. Surprisingly, under PPV parity, which is sometimes also referred to as predictive parity or the outcome test, and also for FOR parity, it can be optimal for decision makers to apply an upper bound threshold for one group, leading to the omission of the most promising individuals. For the scenario of a bank granting loans, this would mean that for one of the groups, individuals who are most likely to default are granted a loan, whereas those who are most likely to pay back their loan are not granted one. Furthermore, our work shows that there is a trade-off between fairness across versus within groups. Within group fairness is in almost all cases violated for all but one of the groups when the group fairness criterion sufficiency must be satisfied. Thanks a lot.